I'll pull the URL back up in just a moment, but just want to show you what's there. It'll open this GitHub repo. And then when you come down to the README, if you want to just do hands-on, then just right-click and open Colab in a new tab in your browser, and then you'll be able to access each of the notebooks. And so if you open up Colab, then one of the tabs on the top will be GitHub, and you can just search in the bar. I'll do this again, but just really quickly. You can type in my name or the GitHub repo. There's a little search icon on the right-hand side. And it didn't open up Vis, so we'll go down to Vis. And then there'll be the 3 notebooks. And if you just click on them, they open in the same browser, in the same tab, and that's annoying. So you can go to the right-hand side and click on any of the square boxes, and they'll open in a new browser tab. So I'll do this again, but when you open, say, number 1, it'll go over to this notebook, and you'll have a notebook available that we'll go through after kind of going through a presentation. So again, the URL at the top of the slide takes you to the repo, and then in the repo you can just open up a Colab interface, search for that repo, Vis 2022, and then open each of the notebooks when we get to them, and it should be a lot of fun. So before we dive into the presentation, I just wanted to get a sense of the audience, wanted to get some feedback from you. I mean, how many people, talking about industry, how many people are coming from academia or industry or government? How many people are coming from schools, academia, university, academics? Nice. And how many people are coming from industry or non-governmental? Nice. And anyone coming from government or some other type of organization? Cool. Yeah, thank you. Good distribution across all different types of industries. And then how about familiarity with regression analysis of any type? You know, familiar with it, used it in the past, or not at all, and it's a new thing? How many people are kind of familiar with various aspects of regression in any way? Nice. Okay. And then if you're less familiar with it, hopefully we'll have fun talking about topics related to regression. And then one other thing I was curious about was different technologies. We all come from different technology backgrounds. Like the tutorials in this tutorial are going to focus on R code, but maybe people are familiar with Python or other visualization technologies. How many people tend to use Python, for example, in their day-to-day work? Here and there. How many people tend to use R? Little bit. And then how many people use other technologies, Tableau or more visualization-focused technologies? Nice. Okay. Well, I should have picked Python instead of R for the presentation because there are more people raising their hand for Python than R, but we'll do that next time. But hopefully the Colab environment will at least feel familiar to those notebook environments. Okay. So again, for anybody who just came in, the URL at the top will take you to a GitHub repo, and we'll use that to access the tutorials. If you want more of a hands-on experience, you can run the code while we're doing it later in the session. Yeah, please.
Can I ask a silly question?
Absolutely.
Does anyone know what the password is for the IEEE Compass? Yeah, what she said, VIS, all capitals, 2022, with a exclamation point in it.
Awesome question for getting access to Wi-Fi. Very cool.
For over 131 years.
So I think we'll start, I'll try to keep the presentation to just the beginning, and then we can transition over to the tutorials, which will be a lot of fun. Different types of regression: linear regression, logistic regression, hierarchical regression. We can pick and choose based on people's interests. Just since we're meeting for the first time, just wanted to introduce myself. Again, my name is Clinton. Have a wife and 2 daughters. I work at Meta, formerly Facebook, as a data scientist, previously at WhatsApp. And I work in an organization, a team that develops the products for the employees of the company, helping them onboard to new teams, change teams, plan their career paths. So there's a bunch of applications and tools to help you develop your career. Outside of that, I've really been interested in learning programming techniques, and so written a few books on the topics. And then I really enjoy education and teaching, and so outside of day-to-day work, I teach a graduate class in interactive data viz at UC Berkeley, and then at NYU Steinhardt teach a graduate class in regression modeling. It's just a little bit about me. So then finally diving into the topic, we're talking about Bayesian regression modeling. We want to do these analyses, and what's the full end-to-end flow? How do we start thinking about the analysis we're going to do, and how do we come to communicating our insights and results to people at the end? It talks about the full flow, and this is the overview of the presentation. You have research questions, you have things that you're interested in figuring out, business opportunities or questions you want to do, and you're thinking that some form of analysis, maybe regression analysis, will be useful for that. And then thinking right away, who's the audience for that? Is it high-level executives? Is it the administrators within your environmental department, your colleagues? The types of information you're going to share with the people that you're going to communicate to at the end will influence, how you're going to pull your presentation together. And then we want to communicate in visualizations, communicate the key insights. So how do we know the foundational concepts, the best practices, and then use those to create visuals and tell a story at the end so that we can communicate our findings and results really effectively to our intended audience. So that's the overview of the presentation. And then what we'll do in the tutorials is walk through those as an analyst, going through our analysis, and then finally creating a visualization that we would communicate with our stakeholders. So just at the beginning of the process, thinking about your research questions, and the two are just so important, the top two, what are you thinking of investigating and why is it important? We'll come back to it in the storytelling piece at the end, but so what? That's going to be the question your audience has is, you're thinking of investigating such and such, or your findings are such and such. Who cares? Are they important? Are they meaningful? Why are they important? Why are they meaningful? So being able to answer these questions up front, sets you up really strongly for being able to tell a compelling story at the end. And then how are we going to communicate the message? And that's highly tied to who's the audience. And please, this can be interactive. If you have thoughts, comments, questions along the way, happy to have a dialogue about it. It's fantastic. And then people coming in and they're coming from not thinking about regression or Bayesian regression. So the title of this talk and the analysis flow that I'm referring to in the Bayesian framework comes from this paper listed at the bottom. And I've just done a simple version of their diagram to give the appearance of it being really iterative. You come in the upper left-hand side, you've done some initial EDA exploratory analysis, you've come up with an initial model, and then in the Bayesian framework, you're going to tie some prior distributions and some data together to come up with posterior distributions, and you're going to use those to report your results. And so initially, do some prior predictive checks to make sure that what you're starting with at the beginning doesn't start from ridiculous assumptions or extreme values. Once you think that the prior predictive check is good, fit the model as you would in regression, doing your predictor variables on your outcome. In Bayesian analysis, when you're really doing it out there in the field, you're going to use some sampling mechanism, MCMC, Markov chain Monte Carlo, and at that point you need to make sure that the computation ran well before you even try to do any inference on the results. If it's not, go back and fix your model, make it better. And then if it is accepted, start thinking about the results of your model, interpreting them. If it's not trustworthy, go back and start again, make it an improvement. And otherwise, you might be doing versions of modeling, trying out different predictor variables. Then you have a couple different versions. And down in the lower right-hand corner, you get to comparing different models and seeing which one is most predictive or most justifiable. So this is kind of the simplified flow that is iterative. You're going to go back and go to multiple phases throughout. Any questions on the flow? Yeah?
I have one question. Is this related to causal modeling?
It's a great question. I didn't set up the tutorials to focus on modeling frameworks that would be designs to try to infer causal inference from the get-go through the design. Like the analysis we're doing is a difference in difference or a matching analysis or something So it is completely applicable, like with what we learned today, if you design your study to try to go for causal inference, then these modeling techniques are directly applicable. But you have to know the additional design to do it that way instead of it being completely observational and just dumping variables in to predict something. So what we're discussing today could be used straight for prediction or for causal inference. And to his question, you need to think, if you're not running an experiment, the design that you set up for your study to lend some credibility to causal inference is really important. And so to his question, it's a great question. I haven't framed it that way as these analyses designed to certain causal inference studies, but it can be used for that.
Because, causal modeling, Bayesian networks is a causal modeling.
Definitely. I touch on it at the end of the presentation where one aspect of this is creating directed acyclic graphs of your assumptions of the way in which different variables affect other variables, creating a DAG of that, a causal DAG. And so that's an important part because it provides so much information before you even do your analysis of communicating to others what variables you think affect other variables. It clarifies it to yourself. And then what's really neat is tools and technologies are developed so that when you put your data into the causal graph, it displays to you the variables that would need to be controlled for given your graph of what to predict the outcome. And it would also, like, you can test those as side analyses to say, given my assumptions about the causal graph, these are the things I need to analyze to test whether they're true, and you could do that. But it's also great for just communicating with others. Here's the way in which I think these variables affect this other variable, and getting out of your head onto a piece of paper, and then people can have discussions and disagreements about it. Let's try to keep interjecting, because that'll be awesome. We can rope it in.
I know how you feel.
It's incredibly important because the distinction we're making if you're a little newer to regression analysis is when you create your matrix of data, if you've collected your data from an experiment, then the way in which people were put into a treatment condition or a control condition is random, as good as random. It's divorced from any of their characteristics. But if you just collect data from your study, your analysis, without any randomization of treatment control, then there's all sorts of self-selection bias of who goes into treatment and who goes into control. The individual people decide that when you're dealing with humans. And so you have to control for all of that. And you either do it through a randomized experiment or study design or regression, but that's the least effective. So we like to stick with design or experiments up front. I like this discussion there are lots of books on regression analysis and in different frameworks. This one is coming, the concept is coming from statistical rethinking, and just the idea that in the past I was taught all of these little procedures, little tests, a t-test and an ANOVA, and all of these little things, and all of the assumptions have to be right for them to be valid, and they're just so fragile and brittle, and you don't need them. We don't need that anymore. You don't have to go full Bayesian regression analysis, but you can just think of all of these little procedures as specific forms of regression. So you don't have to think about these as procedures, just put it in a regression framework, Bayesian or not, and it's flexible. And so all of these things that you've assumed are just simple regressions, and we're going to move to just think about it as regression, and even more so in a Bayesian framework. And you don't have to think about these brittle tools. Just think about the flexibility of regression analysis. Just as a simple example, like the difference in means. You have some outcome variable, and here they're trying to have you do a t-test, and it's a just very specific procedure. But instead, you could put it into regression, and you're looking at the difference in outcome values between two groups. So you have a predictor variable that's ones and zeros, group 1 and group 2. And an outcome variable. And it's just a single predictor variable and a single outcome variable in a regression framework. So you don't have to do a t-test, you can just do a regression analysis as one example. But you could do the same for all of these others that are mentioned here. So thinking about the phases of the analysis, up front, I thought about putting in even before this is the design, the thinking of the research question, the so what, the design that the audience member was talking about. But let's just start with, you've thought about all of that and you're starting your analysis, because then we can just start with the Bayesian regression framework. And that's the whole exploration phase. You know, you're doing exploration analysis, you're trying out different models, seeing which of your assumptions are valid, which ones aren't, and going through this whole process. But eventually you need to come up with what were the insights you gleaned, the results you had, and how do you communicate those effectively. And the main point of the presentation is that the quick and dirty graph visualizations you create for yourself to discover the insights aren't sufficient for communicating the findings to others. So they're absolutely fine for your phase. You're familiar with your data, how to interpret the charts that you've created for yourself, and then you need to modify them for others. I think one of the other textbooks we use in our course is the Visualization Analysis and Design by Tamara Munzner, and she talks about these as different tasks. You know, there's the whole exploration discovery task phase, and then the communication presentation phase. They're different tasks. And so we're going to customize the visualizations we design to support these different tasks. And it's important for both. You know, even in the exploration phase, when you're kind of exploring your data, trying to figure out what's important or what distributions are there, if you just left it in your data table form, it's really hard to see. You know, this is the Anscombe's quartet, where your variables have the same mean and variance or standard deviation, same correlation between each other. If they're just in table form, you can't tell what's going on visually. And so as soon as you create visualizations, you kind of see, oh, here are the extreme values. Here's, you know, it's not a normal distribution. There's a very different distribution in my data, and that's just useful for the modeling you're about to do. So it's incredibly valuable even during the exploration phase. But then these aren't sufficient for communicating with your admin or the executives at the company. You need to create visualizations that can communicate your findings. They're no longer descriptive, they're communicating insights and findings. And so this one was from a paper that I just really enjoyed, where the person was taking publications that had been done in academic journals and creating much better versions of them. So yeah, down at the bottom, the Economist's Guide to Visualizing Data. This one, the version that got published was just, I think he called it a cluster plot or a clutter plot. It was very, very detailed and hard to read. And so instead, figure out what the story is, accentuate the data values that are part of the story, and mute other things. And we'll just talk about that throughout the day. Does that make sense? There's kind of two phases. The exploration analysis phase, you're creating stuff for yourself. It can be a little more quick and dirty because you know what's going on, but then you need to create much more polished versions to communicate with your stakeholders.
I would think that's a very strong correlation.
Yeah. Totally. In the original paper, the people had used the 3-letter country codes instead of dots, and so it was just a mess of letters, and you could not tell, and they had done no distinction between points, and so they were all the same color. And so if the only story was something about the correlation, fine, but they wanted to communicate some story about these countries that were, and it's a great example of kind of figure out your story and then communicate that, not 3-letter codes. Nobody could understand what was going on. So we're thinking about visualization, just wanting to make sure we do a good job with our foundational concepts, our best practices. You know, how would we know that we got there? How would we say, you know, we're evaluating our visualizations against some criteria to say that they're effective? We want them to be truthful, functional, beautiful, insightful, enlightening. This is coming from the truthful art. Just lots of, you know, aspirational goals. We want this thing to reflect what we found in the data. We did everything honestly and truthfully, representing it as well as we can, making it beautiful and insightful that people can glean the insight that we're trying to convey through our visualizations, and changing minds for the better if people are able to grasp what we're trying to communicate, you know, trying to make progress. So lots of helpful kind of key qualities that we're going for when we try to create our visualizations. So we're going for effective visualizations that have those qualities. What are the different types of knowledge that we need to get there? We need to understand our audience. Who's the audience? Is it our immediate colleagues or high-level execs? And what do you want them to know or do when they come away? I mean, it's just so important. Like, what do you want them to know or do differently, having communicated to them? You want them to know some new insight. I want to hammer home the point of thinking about so what. You know, that's going to be the first question in their mind is, you just told me something. Why does it matter? Is it important? So what? And being able to answer that effectively is really, really useful. To get into the visualization of data, then we need to think about foundational visualization concepts, the marks we're using, the channels we're encoding data through, and then the effectiveness of different channels for communicating effectively, the channel rankings. So we'll be talking about marks, channels, and channel rankings. And then there's just a whole slew of best practices, guidelines, things like that, that's just useful to wrap into the whole collection of information we think about for creating our visualizations. There's a whole bunch of common or standard graphic forms for different visualizations, and you don't want to run away from them just because you want to try something new and different. In some cases, they're an effective form for communicating that insight. So start from those, and then you can modify them, customize them for your own view. Creating the visual hierarchy and directing attention is wrapped in with using color strategically. Communicate the insight you're trying to convey. Direct the user's attention, the viewer's attention, to what you want them to see. Removing clutter and facilitating comparisons. All visualizations are these comparisons. People are looking for the meaning, certain values relative to other ones. So just trying to make that all very, very apparent to the users. Here is what I want you to glean from what I'm displaying. And then annotation ends up being so important. The title, the subtitle, it should not be descriptive. This is going back to the so what. It should not be, population distribution of people at the university. Like, the person is going to say, so what? What am I supposed to know from this visualization? That something is changing, that something has decreased dramatically. Like, what is the takeaway message? So that comes into play with annotation, really important. And then people are coming from Python and other technologies. For this presentation, I'm doing it in the context of R, but thinking about just layering grammar of graphics, being able to think of the visualizations we create as layers of marks and text and annotation just becomes really, really useful for thinking about how we put different layers of information together for the final visualization. So it'll be in the context of layered grammar of graphics that has gone into ggplot2 in R, but it translates to any other technology you're using to think about plots, not as a named plot. I am going to create a box plot, I'm going to create a bar plot, but thinking of them as components that have been layered together to create a visualization. And then just so important, going back to the storytelling, like thinking of core concepts within storytelling to communicate your insight or finding. What is the big idea, the one key message you want the users to come away with? Just incredibly important. SPAR will be a fun acronym for making sure that the so what is clearly communicated. Bing, bang, bongo, the beginning, middle, end. Just making sure that your presentation or paper communication flows. You introduce people to the concept really well at the beginning, explain all the details in the middle, and tell them what their key takeaway or action item should be at the end. And then storyboarding and horizontal and vertical logic are for your paper or your presentation, making sure that the flow of the presentation makes sense and that the information on each slide makes sense. If you want to jump ahead in any of this or just be able to see it on your own screen and in your own time, it's one of the links in the GitHub repo. So feel free to just go to the GitHub repo and open it up, and then you can flip back and forth to wherever you'd like to be in the deck. So thinking about audience, just again, hammering it home, who is the audience? Who are you going to be communicating to? What do they want to know? What are their key interests? And being able to communicate to them effectively. And I love this last question. What does a successful outcome look like? Sometimes you want them to change their mind about something, to fund an opportunity, to take an action. Just thinking about that really, really clearly. So you know the way in which you're framing your study to provide them with the information they need to do what you want them to do. So finally getting into Viz concepts. Some of this is coming from visualization analysis and design. So thinking about the marks we're putting on the page, they're just foundational marks, points, lines, areas, and then they're the geometric shapes that we're going to use to convey information, and then we can use different channels within each of these to convey more information about them. Is everybody already familiar with all of this? Or people coming from visualization? So we have our points, we have our lines, they're going to represent some different types of data. We can change their attributes to punch more data, more information into the geometric shapes that we're using. So even just for points, we can position them along an axis, whether it's horizontal or vertical, to convey some quantitative attribute. We can change their color. And if we're using hue, then we can say that these sets of shapes are part of one group and these other points that are part of a different group are a different shade of hue. We can change their shape to convey categories. And then size, area, volume, just all different ways to pack more information into the shapes, either their length, their position, their color, their size, to punch a lot of information into each of the shapes that we're using, whether they're circles or lines or areas. And then a lot of research has been done on the effectiveness of different channels for encoding certain types of information. And so you can think of the expressiveness and effectiveness of using different channels. And prior research, both back in the 80s and more recently, has supported this ranking of the effectiveness of different channels for different mark types. And so if on the left-hand side, we're looking at conveying ordered information, continuous information, quantitative information. It could just be small, medium, large, ordinal, but it could be fully continuous, just unemployment rate, something that's fully continuous. Or on the right-hand side, identity channels are conveying categories, discrete bins, dimensions, things that you'd put stuff in different categories. And so at the very top, positioning along a common scale, just like we would with scatter plots, you have an x-axis and y, both conveying some quantitative information, that wherever you put the point in the plot is along some common axis, both in the x and the y direction. But then if you start on the right-hand side, if you'd like to say these circles are people that were treated, and these other circles are people that were controls, not treated, then maybe you want to use color hue for binning them or categorizing them as treated and control. So just from top to bottom is the ranking of effectiveness of different attributes. So you can just think about that as you're trying to put your plot together and say, which attributes should I use first to convey the most important information? This one comes up so common in some of our coursework, especially the use of color, where people really just kind of either get confused initially on the use of when to use color hue versus luminance or saturation. People may even want to use color hue too often and create a plot that's just very, very colored, and it's confusing what the takeaway message is. So part of the fun in communicating this is saying, let's be really thoughtful about the use of color to just accentuate what you want the main message to be. And then it's just this wonderful aha moment of let's start with everything in gray and then add color to convey some finding or insight is one method for getting started. So just thinking about visualization designs, best practices, these are just standard graphic forms. These are very common, and they might be effective and useful for the key message you're trying to take away. Simple text, if it's a very simple message, you can just convey with text. Scatter plots, tables, lines, heat maps, slope graphs, and then a bunch of different bars. I mean, this came up for work the other day when we were just trying to convey a simple quantitative measure for a bunch of categories, and a simple bar plot or column bar worked sufficiently. Like that conveyed the main message of what was going on in these different categories. So you don't need to come up with something complicated or different just because. You can stick with these. And this was just another visual representation of the effectiveness of different channels for conveying information. So just in multiple texts, you can see, start with whatever your main message is and the data you want to convey, start with the most effective channels for those, and then move down the list. And then creating visual hierarchy, or just being able to think about how we perceive information on a page, just being aware of some of the principles of proximity, similarity, just sticking with similarity because it's fun. The points are just scattered across on the page, and without the color distinction, we wouldn't really group the ones that tend to be blue together. There's a portion that's off in the upper right, there's a portion in the lower, and there's a portion on the side, and we would just think of them as 3 different groups because of the proximity. But as soon as we add the color distinction, then we group together the blues and the yellows because of their similarity on that attribute. So similarly with enclosure or common fate, those are all really fun, cool examples online where there are 2 lines that cross, and it would make most sense to have your eyes perceive them as flowing in similar directions, but they change the color, and your eye has a tendency to move with the color, even though it's not the most common flow, as an example for common fate. But we can use these to create very simple plots to do away with a lot of the axes and the grid lines, and all of that can go away because we'll perceive them as grouped visually when we add the color for the bars or the circles. Figure and ground. How many people have seen like the vase of 2 faces, and your eyes kind of bounce back and forth between looking at the vase as the foreground versus the 2 sides faces as foreground? There are lots of cool examples of changing what is in the foreground versus the background, and very fun. Just keep it in mind when you're creating visualizations. And then talking about drawing attention. There's so many ways to do it with the geometric shapes, the graphical marks we're using, and then in a moment we'll look at, you can even do it with text, just draw people's attention. And so depending on what your main message is, you can do that with the length or the width or the size. Like make sure that the big thing you're trying to convey is the larger size. Or color distinction, and this is the one we were referring to earlier, where most of the data, and in an earlier slide, most of the points on the scatter plot were gray. They weren't the main message. Add color to accentuate the ones that are part of the story you want to tell, the key insight or finding. Spatial grouping, really, really useful in tables for ensuring that somebody sees rows where there should be rows or columns where there should be columns. You just change the spacing slightly, and we visually perceive it as rows or columns one way or another. And then again, even in the tables, then you can get rid of a lot of the lines, thick lines, because we'll perceive the rows really well. It's not just for the geometric shapes, also for the text. We can use color. So in the upper left-hand corner is not accentuating anything, it's just a paragraph of text. And that can be hard to say, what am I supposed to focus on? And so instead, you could make something pop with color, or with the sizing, or literally enclosing it in a rectangle, italicizing it. So there's lots of ways, even with text, to say, this is important, pay attention here. All of the rest is just context. I always love this one, because it's like the final revision on the visualizations or the paper that we talk about is, is there something I really need them to pay attention to? Find the appropriate way to make that pop. We already talked about this one, but this comes up so often, the distinction in when to use one type of color versus another. Color hue for different categories versus luminance and saturation for things that are inherently ordered. If you're trying to convey unemployment rates, you want to use that luminance or saturation. There is an ordering to those values versus different categories being different hues. Another one that comes up all the time, I'm sure you've seen this one, is where there's an inherent order, say unemployment rate, and somebody uses a diverging color scheme and has some midpoint at some middle value within the scheme. And it just is injecting storytelling and rhetoric where you may want it for some purpose, but if you're not doing it intentionally, then you're injecting some rhetoric or storytelling there that shouldn't be there. So you could just use a single hue sequential. That comes up all the time. And so just knowing the distinction between when to use one type of color versus another and when you're doing something intentionally to convey a story versus just conveying the data in an ordered way is really, really important. So going back to using color intentionally and thoughtfully, just a simple way to get started is to just make your plot gray and then decide where to add color to convey the story you want to tell. So these are just examples of move everything to gray and then what do you want to pop? And this will direct people's attention and tell a story that you want them to tell. Removing clutter. I love this one. You know, just by the defaults in all of the packages we use, they're trying to provide a default plot that is pretty good for all scenarios, but that means that it's not wonderful for your scenario. And so in the upper left-hand corner, there's the starting plot with the heavy grid lines, the box, just so many different things that are cluttering the visualization. And as you move to the right and then down, this is coming from the Storytelling with Data book, you come to a visualization that's very clean, very easy to read. The labeling is right next to the lines, similar coloring coding, so you can connect those without some distant label. And there's no visual clutter from all the grid lines and outline. And you can see that we don't need those, like from all of those Gestalt principles that we talked about at the beginning, we see that area, that white space between the two X and Y axes as a confined plot space. Your mind just sees it as a single plot area. And so we don't need a lot of grid lines or box to say this is my plot. We perceive it that way, given our familiarity with these plots. So I think from one of the historical texts, it's earlier text on it, it's enhance the data ink and remove the non-data ink would be the catchphrase from visualization of quantitative data. The importance of comparisons. You know, might be familiar with the stacked bar plots shown on the left-hand side, where it's very easy to compare the segments that are aligned along a common baseline. It's not as easy to compare the sections that are not aligned along common baseline. So if you have the opportunity to create interactive plots where somebody could select which category should be on the bottom axis, you're giving them that added flexibility to be able to make true comparisons with a standard baseline. And if you can't inject interactivity into the plot, then thinking again about what is the insight you want to convey and put those segments down on the bottom axis so it's easy to make the comparisons along the x-axis. And then similarly, maybe your story is something about observations that are relative to average, they're higher or less than. And so in this story it is, I want to make a comparison between observations that are higher than average versus lower. And so put the average line in there for visual comparison, and then use color distinction to say, pay attention to these dots. They're the ones I colored. They're the ones that should be compared to the average line. So. And then finally, the real big one, annotating with text. You know, the generic form is on the left-hand side of having a really descriptive header that tells the story you want to tell, maybe even subheader. X and Y labels with the units, you know, what were the variables measured in? Sometimes they put height, you know, and is it inches, centimeters? Like what are the units of that measurement? It becomes really interesting when you've come up with a variable that's a custom variable that you've calculated. You want to let people know what it represents. What are the units of that measure? And then in some instances, it makes sense to say who created it and what is the data source, so that somebody who comes to the visualization later has a contact and a data source to discuss and get back with that person to understand the visualization best. And so here's an example on the right-hand side where somebody is telling the story, like what is the action that the person who created the viz wants the viewers to take is approve the hire of 2 FTEs. And then they tell a story with the visualization to say why that's needed and why that's important. So it's not ticket volume over time is not the title. The title in this one is, here's the action I need you to take. And then the visualization is why. Just more examples of being able to annotate. The person adds some paragraphs of text, again with some of the text within it bolded to accentuate what she wants the viewer to take away. It's all left-hand aligned to make it really easy to read. It's not centered and jagged along the edges. And it is with a key title at the top. And then similarly on the left-hand side where they've started injecting some color distinction and drawing your attention to the deep saturation with the deep red, and then a little bit of saturation with the medium pink, and then grays. And some of the text has similar red bolding to link the text with the sections in the paragraph. So then coming to grammar of graphics, we want to create these plots, communicate with our stakeholders. Here's one way in which to do that. There's been an evolution in the process, so the semiology of graphics created these examples that talked about using different points, mark types, and then what information they could convey or be relevant for different attributes of changing those mark types. And so here's an example from the way in which we started to learn about changing the attributes of different mark types to convey different types of information, whether it's the texture, color, orientation, or shape, or size and value. And so those got built upon within the grammar of graphics by Wilkinson, and then more recently, Hadley Wickham kind of modified it and extended it for programming language, and now it's available in this programming language that is available elsewhere. So it's been an evolution to kind of figure out how to create this, and that gets extended to other technologies that you might be familiar with. So within the layer, just different components to think about a given layer. We want to pass in a data set and then a geome. That's the geometric shape. Those are our circles, our lines, our areas, our hexbins, our tiles, whatever type of geometric shape it is. And then you can see we can pass in aesthetics or attributes to change its attributes given those channel rankings we talked about. We need it to be a certain color, a certain length, a certain width. And so you can pass all of that information in. So then talking about how it works, just to show examples of it. Within ggplot, if you create the ggplot function and you pass in a certain data set, then you can say, I'm going to need one of my variables along the x-axis, one of the variables along the y, and when you just create that plot, it creates the graphic space, but it doesn't produce the plot, because you haven't added any geometric shapes there, any data. So we had created the plot as P, and you could just build this as a long set of code, but just to make it look really simple on the left-hand side, we're just going to have all the original plot code wrapped in P, and then we'll just start adding our layers one at a time. And so now we want points, and then you get to see our classic scatter plot. But there are different vehicle types in here. There's other information we could convey, but right now we can't tell them apart at all. So let's start adding additional layers. Add information. So there are a bunch of different car types, and so we can start changing, add the color hue to categorize these plots as coming from different car types. We're getting closer to saying, is there some relationship between displacement and the other variable by different car types, and being able to see that through color. Trying to get a sense literally of the relationship between that, you can see that it seems in the dots. When you're looking at the dots, it seems nonlinear, so putting a straight linear regression on there doesn't make sense. So let's try LOS just to have it be a little more flexible, and then being able to start adding some annotation. So just to show the importance of the annotation, if you go back to the previous one, there's no title. The X variable literally is displ. Like, I don't know what that is. And HWY, I don't really know what that is. And if I handed that to you, you wouldn't know what those represent or the units. And so that final step of adding an informative title, even a caption, and then descriptive X and Y axes with the units that they're in is just critical for communicating to other people. So it's a key piece of creating the visualization. Okay, any questions on kind of grammar of graphics, building a plot up layer by layer? Then we can get to storytelling. This one's fun. So thinking about the different ways in which we pull stories together to communicate our findings and our results. From this text, Resonate, one idea to think about is, what is your big idea? What is the one message that you want to convey in what you're presenting to other people? They have an example in this table on the right-hand side where it's just like when you come up with a thesis for a paper. It needs to be specific, and it needs to answer the question, so what? These ideas on the left, lunar mission, client sales call, like, are topics, but they don't convey the insight that you want to glean or the key message or why it's important. So it needs to be your unique point of view, conveys what at stake, and be a complete sentence, as described on the right-hand side in examples. You know, what do you want the person to know or do, and why is that important? And you can't do that with a little catchphrase topic on the left-hand side. Sometimes this is just the most critical part of even initiating your research, is thinking about what am I interested in figuring out, and why would that be important? Or what magnitude of change should I find that would be meaningful? So what's your big idea is a complete sentence that conveys your point of view of, you know, what you have found and why that's meaningful. And then how do you make it punchy? You know, you want to convey this to others. It wants to be grabby. You want to answer that question, so what? Why is it important? It should be succinct, provocative, actionable, relevant. And then I have little descriptions of, you know, how you try to wrap that into your initial TLDR, your initial abstract, whatever you call that initial little blurb that says, here's what I'm seeking to find, here's what I found, and here's why it's important. And doing that in a useful way. What's really fun is sometimes that could be really useful with the visualization. Like your visualization is your punchy piece that conveys your main message, and you just put some explanatory text around it to convey why that is important or what you need somebody to do. Remember the visualization a little while ago that was, you know, please approve these 2 new hires, and here's why. That could be the main message, and then just a little description of how to interpret the plot. So the relevancy, provocative, actionable, like what is the insight that you found? Why is that meaningful? Does anybody have good examples that they immediately think of where they saw a good example of this or a horrendous one? So one of the email lists that I subscribe to is, it's either the Bureau of Labor Statistics or some government agency that'll send you a chart per day. And I love getting those visualizations just to be reminded of the different ways in which they create visuals for different labor statistics or census statistics. Fantastic, but because they have to put them out daily, they're completely descriptive, and they do not answer the question, so what? You know, so it is a little chart that says, here's this variable, and here's the plot of the variable, and it's uninteresting. And for a daily email, like I subscribe to that, it's wonderful, it's fine, but if you're conveying to stakeholders, it should be much more apparent. What is the key takeaway message of the plot you created? Why does it matter?
Is that from Fred?
Say it again.
Is it from FRED?
It wasn't FRED. I'm pretty sure it's census or BLS, and I'm sorry to call that out as an example because I love getting the emails, but when you get them, it's a visualization and a description of the data. And I open it up and say, that's interesting, who cares, so what, and then slough on. But if you find that similarly with Fred, like if there are ones that they're doing and they have a little more time to curate and provide here's what's happened over 6 months and put a little more description in, that'd be really cool. I'd enjoy that. Like, what should I take away from this visual? Just like with our article writing, you know, beginning, middle, end, getting that structured well, it's another important part of story. You know, the setup in the intro is that spar, is that, you know, here's what I sought to find, here's what I found, and here's why that matters. And then in the middle is some description of all of the things you did to figure out that that was true. And in conclusion, what do you want that person to know or do? You know, what is the key takeaway message or call to action? What should they do with this information? And just kind of structuring this ahead of time so you think of how do you get somebody interested in what you wrote, how do you describe all the things that you did and your cool findings, and then what should they know or do at the end? What's the key message? Whether it's your paper or a slide deck, I love this example from Storytelling with Data, these next 2 slides, horizontal logic and vertical logic. Horizontal logic is, can you just read the slide titles from each of the slides, and together they tell the overarching story? So I have tried to do this in a sense, but she also says it's important for these to be action titles, and for mine, I purposely made them more descriptive. But if you've done an analysis and you are walking somebody through your analysis, through your slides, it is, you know, what was the key thing that you were trying to investigate? Why was that important? What did you find, and what's the call to action takeaway? So making sure that that story flows really well is an important part of putting your paper or your presentation together. And you can do that literally with informative titles that move people through the presentation. Similarly, within a given slide, within a given paragraph, so you can think about this as writing or a PowerPoint slide deck. Within a given slide, is all of the information on that slide self-reinforcing? Does the title communicate the main message of the visualization? Does the visualization tie to the text in the main? Just making sure it all ties together. It's so interesting how many times myself or teammates have come back to a slide deck and we've kind of seen 2 or 3 main messages on a slide, and that's just, it's too much. Somebody's trying to inject all that in at the same time, and it's very confusing. So if you can just pick one message per slide, make sure all the content on the slide is self-reinforcing, really, really useful. So what's an easy way to do this, an effective way to do this, is low tech, paper and pencil, and do it ahead of time before you get into any of the technology. So I love, the person who did this book, Storytelling with Data, she has an example online of her storyboarding with sticky notes for her chapter to just outline the way in which she wants a chapter to flow. Yeah?
Actually, I got a quick question about sort of the couple other principles that you just covered.
Yeah.
When I looked at the example where you showed, like, please hire 2 FTEs, right?
Yeah.
That kind of jumped straight into the conclusion. And for sort of a stakeholder, I would want to know why first, right? So instead of, like, so would it be an effective way to say we're in trouble? Or,
Gotcha.
issues, like, basically to engage the stakeholder who's responsible for making sure that we are, covering the pipeline well, right? Like,
Yep.
Technically breaks this principle, but it probably would engage, like, a stakeholder more, if you could communicate the trouble, and then you can essentially, get them to think one of the ways you think is most effective way to handle it.
It's an awesome question. Like, yes. So I think what you're asking is kind of at the interplay of that piece of making sure that your communication is directing thought or action with the first piece of knowing audience. And so I think to your point, it really, really pays to know the state of information in the people you're communicating to. So if that's communicating with the head of your department or organization or my org, and we want somebody to be hiring, knowing whether the person you're communicating to is aware of the issue ahead of time or feels the same way as you do and has communicated that before, I think the interplay of what information do you think that person has is really, really useful for knowing whether the slide before that one is here was the problem, or if you know the person already knows that, or that was the question in their mind, and they said, I don't know if we should hire anybody else. Can you go figure that out? And then if you knew that they were already thinking about it, the slide could be, yes, go hire 2 people, and here's why. But to your point, you need to think about both. Yeah, it's an awesome question. And then I just had to take a picture of my work on this one. I mean, this is me storyboarding this presentation from a variety of books, putting ideas down on note cards, rearranging multiple times, trying to figure out some flow. So hopefully this presentation felt like it had some kind of flow from table of contents and then straight on through. But effort went into that, and low tech. Just write down the topics and ideas that you want to organize them outside of any technology first, because then it's easy to put it back into the slides or the paper. But how many people have done storyboarding or like organizing their ideas before they write up their paper or put a presentation together or something like that? Yeah, awesome. I mean, it's really, really useful. Just kind of little blurbs of the thing you think, and then where should that fit in my narrative? It was actually fun. So we're almost at time to switch over and start doing the tutorials. So just to flip through some visualizations for finally going back to, we're doing specific type of regression analysis. It's been a long time since I threw up the Bayesian workflow, so just throwing that up. So we have a model, we check some of creating the model and its results, and if we do it, then we start comparing different models. Otherwise, we go back and fix things that we thought weren't good yet. starts with exploratory analysis of different variables. Look at all the different visualizations we have at our disposal to check distributions of variables, compare them to distributions we're wondering if they are alike. You know, are they log normal? Are they normal? Are they skewed? Are they symmetric? All of these are kind of understanding each of the variables, get a sense of the data before modeling it. The previous plots were kind of all on a single variable, getting to know that variable, but then you might want to look at relationships between variables, get a sense of how they covary together, at least in a bivariate way. You can create all different plots. There's all different technologies for these types of static plots to just see how are these two variables related? Are there outliers in different space? Like, just understand it before you try to model it. And then we finally come to the topic that we were talking about right at the beginning about causal DAGs and causal inference. And so there are technologies. The one I'm referring to here is Daggity. You can go to daggity.net, and it's really fun. It has a GUI interface where you can create little boxes for the variables that you're thinking are useful for your analysis and draw arrows to say, I think this variable affects this variable causally. And you draw this diagram, and then what you can request is, okay, if I think this is the reality of how the variables affect one another, which relationships should I test to see if this causal DAG holds up to the data I have? Does the data support my view of the world? And then if it does, then you have different designs you can test. In this case, thinking these two different variables make their way down and affect this one, whereas this other model, you don't think M affects D. And you can test those distinctions in your modeling efforts, and that would be testing some research hypothesis whether one does or does not affect the final outcome. Have absolutely done this one at work. Just, it is a fantastic thinking tool and communication tool. I mean, you have this floating idea of the way in which different variables affect other variables in your head, write them down on a piece of paper or with this tool, and once it's straight in your mind, you can use it for your modeling efforts, but you can also communicate it to others and they can critique and say, you know, I think you forgot a variable in between these two, or yeah, that's a strong link. We found a result that supports that in the past, and you have a better sense of it. So these are incredibly useful. Specifically for Bayesian regression analysis, for all of the variables or parameters that you're going to estimate, you've got to supply a prior for them, and then you're going to supply your data, and there's going to be some meshing of those two to come up with a posterior for each of them. So to get started, you got to come up with a prior for all these parameters, and this example, again from statistical rethinking, was be thoughtful about it. These lines, you're looking at some relationship between human height and human weight. And the dotted line at the bottom is height of 0, is a human embryo, no height, just no height. And then the line at the top is the world's tallest person ever. And so the author is just saying, if you pick this one default prior that many people do, centered on 0 with a standard deviation of 10, so out 2 standard deviations is even farther, then you get these relationships between height and weight that take you from human embryo to world's tallest person ever. And you get negative relationship between height and weight, which we know on average isn't true. On average, the relationship between height and weight is increasing. And so the person describes modifying them to a slightly different distribution that is still flexible, but injects some of your domain and scientific knowledge into it to make sure it's reasonable before you even get started. So it's totally good to inject your domain knowledge, your scientific expertise into the priors that you start with. Then you dump it into your machinery, and it starts doing its MC-MC sampling, and it's trying to figure out what the most likely parameter values are for each of the ones you're interested in. If you're coming from other language, it might be your beta coefficients, your weights, whatever you call them, you know, your weights, your beta coefficients in your regression. And you want to make sure that that sampling methodology worked well. And so there's different plots, trace plots and trank plots, where I love the description of, like, all authors on trace plots is they should look like a big furry caterpillar. And if they look like they're a big furry caterpillar, they're sampling well. They're all in the same region, especially in the white region. Everything in the gray gets sloughed off. And then similarly for trank plots, you want to make sure they're very overlapping, that they're sampling different common space in each one. And so if If they look like they're overlapping throughout the sampling interval, and these look like big furry caterpillars, then your machinery worked well. Once you do that, then you get samples out for each of your beta coefficients, your weights, your samples, and then you can look at those. And so you've got your intercepts of A's and your slopes of B's and your final sigma for the normal distribution, and you can see relationships between them. I think in this one, for people who are familiar with it, if you center your variables, then you're making them uncorrelated, and so you get these nice scatters of points. Whereas if you leave them in their original form and do the regression, in many cases they'll be highly correlated, and you'll get more ovalish shapes of points. So anyway, you can look at what are the common values, the likely values for each of your intercepts and slopes and things like that, just like you would in any other regression. Similarly, more visualizations, just for making sure the variables have the distributions you like, and it's 10, so let's move on. With all different types of visualizations, you want to check for non-normality outliers, just kind of making sure all of the assumptions that you've built into your modeling hold water, or if they're affected, doing some transformations to your variables to address those. So this is just some plots that you can use that are available in the Bayesian framework for looking for those outliers. Same, you would look at your residual plots to kind of see if there's some pattern in the distribution, and then you would want to change your modeling to make sure that you do away with that pattern. One cool thing with regressions is you have your original data, that your outcome variable, your y, your outcome, that's say in the dark blue line in these distributions, and you've created this model, and then it can produce new outcome variable. And you want to see data, and you want to see if the new outcome variables and data that your model produces look like what you passed into the model. Can it reproduce data it saw? And so these two different models show the ability of the model that you've created to reproduce the outcome variable, the y, the thing you were trying to predict, and whether visually it looks like it's close or not. This is an example of a Poisson regression where somebody does Poisson and then negative binomial. Poisson looks ridiculous. It doesn't predict well. Negative binomial gets a lot better. And so it's a way to visually say, maybe I need to change to a different model because the first one can't even produce the data it saw. And then just a fantastic one is plot your data and then the regression lines you've produced on top of it and make sure it looks like it makes sense. In the first tutorial and the second tutorial for linear regression, logistic regression, I purposely created ones that are examples of the scatter plots are nonlinear. And I can't tell you how many times somebody has shown the dots that are inherently curved and they fit a linear regression to it. And when you plot the data and the linear regression line, it looks silly. It's just, you need to account for the curvature in the data. Here's an example of that. So relationship between height and weight in a population, there is curvature, and you could fit a linear regression and your model would be like, here's the line that fits the data, and as soon as you plot it on the data, you're like, that's not very good. And so you could change to other types of models. And these are just more and more examples of plotting regression lines over data to confirm that they seem like they make sense with the data that it saw. And then finally, you've gone through all of this iterative process of exploring different models that might be the best explanations of your data and being able to compare them quantitatively and presenting results visually about the quantitative comparison of different models. And here's one doing it with WAIC for Bayesian models, but you could do any other type of model comparison for different models. Okay. The different texts are shown in the end. And so I think what I wanted to do was have time right before they do the 10:15 break to kind of open up the first notebook and start downloading the packages and things like that, so that when we come back, we can start doing the tutorials. So if you'd like to. Otherwise, you can just follow along with them. So that was the presentation. If you go to the GitHub repo, for people who haven't had a chance to, you just scroll down, and the section to open the notebooks in Google Colab, you would just right-click on this link to open it in a new browser tab. So we can do that. And then we're going to click on the GitHub tab and copy and paste this link to just get there immediately. So I'll copy that here. So this is a Colab environment. People often put the Python code in it. It's using your Google Drive, and it provides you with compute and storage resources automatically, and has many of the packages you would use built in. If I had done the examples in Python, they would just be available, but I did it in R this time, so we need to load some R packages into the environment. So you click on the GitHub tab, and then you can link to any repo that you find online to be able to run their code. So just copy and paste the URL in, and then hit the little search icon on the right-hand side. For some reason, that still didn't bring up this Vis 2022 repo for me. So you can click on the little arrow on the right-hand side and go down to Vis 2022. And then we have 3 to go through if we have time, but we could just stick with one and go through it in depth if people are interested. And what you want to do is click on the box on the right-hand side so it opens in a new browser tab. And you could do that with the other 2 as well if you just want separate tabs. So then you come to the first notebook. And in a Colab notebook, in the upper right-hand corner, you can click on Connect to load the notebook and get the compute and storage resources. You can see you have RAM and disk available. And then you just click into the first code cell, and you can click on the play button, or you can do Shift-Enter or whatever it is on your computer to run the code. And it says, not authored by Google, run anyway. And then when there's output, if you don't want to see it, you can just hover on the left-hand side. There's a little X, and you can clear the output. The cell that's going to take a little bit of time is this second one. So I would just say kick it off, let it run. And I can talk about a little bit about this first example while it's loading, and then it'll probably be time for break. We'll come back, and it'll all be loaded. In 2011, I was trying to recall the year, there was this Economist article on the relationship between corruption and development. And people have since created great tutorials for people who want to learn plotting in R or Python to try to recreate the visualization they created in the article. So they have a little description of, we've looked at the relationship between this corruption index and the human development index, and this was the plot that they created in the article. And then people have created tutorials to say, how do we create that? So they've requested the data from the Economist, got the data, and then we try to go from the first thing that gets plotted, if you just default human development index and corruption index into a ggplot, what's the default plot? And then how do we make it look like that, which is layers upon layers of customization. So that's the first exercise, and the reason I like this one is, again, because the points are curved. And so we can't just fit a linear regression to this. We'll do that and then look at how it looks silly, but we need to come up with a way of creating the curved regression line. And then customizing the plot to use color schemes effectively, do away with a lot of the grid lines, things like that. But that's where this example is coming from, is from this article. So this is just an image, again, of what we're going for. And then I link to that page here. So if you want to click on out to it and be able to read the little blurb that they had for the article, that's fine. This is still loading, so we can't run anything yet. But just to kind of give a sense of where we're going, I guess, while we have time. And then we'll do the break and come back and be able to do this. Loading the packages takes about 10 minutes. So the data are available online. I put them in our GitHub repo, so we'll just read it in. Just looking at the data. The region of the world that different countries are associated with is a categorical factor, or needs to be represented that way in the data, but it isn't by default, so we just need to convert that variable from text to factor variable, categorical variable. We can do some exploratory data analysis. the main focus will be on relationships between different regions of the world. And so just getting a sense of the two variables we have, HDI and CPI, what are their average values? And then, like we talked about when we were doing the exploratory viz piece, starting to do some exploratory visualization to look at the relationship between the data. And so even in this first early plot where we're just doing it for ourselves, we can see the curvature in the data and use a color overlay to get a sense of whether there's relationships between different regions of the world. Talking about, we'll get into it, being able to customize different color schemes and what have you. Okay, so while that one's running, let me just give a heads up on the other two. So the second one we could do is on logistic regression. Remember that's one where the outcome variable is just zeros and ones. One category of people did do something, and another category of people did not do something. Treatment, control, whatever the outcome variable is. In this case, I love this example from another text, Regression in Other Stories, where the authors are looking at whether people in this region of the world, they find out that they are close to different wells that are of varying levels of cleanliness. And then given that the well they're using to get their water is not clean, do they switch to a different well, the nearest well that's clean? And so you might think that whether you switch to a new well depends on, well, how dirty is it? Is it only a little dirty? Is it really unsafe? You know, so the degree of arsenic in the water is kind of affecting your degree of change. And also, okay, right now I just have to walk, you know, down the block to get the water, but the next nearest one to me is 2 miles. So distance matters too. So with those two variables, like how dirty is it and how far do I have to go to get the clean water, are the two variables that they look at. And so I just love it as an example of probability of switching to a new well, given the uncleanliness of your water and how far you'd have to go to get clean water. So again, if you're interested in this one, as we work through tutorial 1, feel free to kick off the imports in this one as well to make sure that they load. And then the final one, if we're talking about hierarchical. This one was kind of what kicked off the whole idea of even giving a presentation on this topic, was an article with the same title, Visualization in Bayesian Workflow. It's an awesome article on the importance of visualization throughout the whole Bayesian workflow process, from exploratory data analysis, initial idea exploration, through analysis, and finally to communication. And so I highly recommend it, very fun to read, and talks about Bayesian analysis. And what they're looking at is, again, these kind of regions of world. And so they were looking at the relationship between these two variables. They want to be able to predict particulate matter in air in different places. And in some cases, in some areas of the world, they didn't have measurements from stations, so they were going to use satellite imagery to be able to convey whether the particulate matter is the level of PM there. And so they wanted to see, you know, how good is our satellite imagery able to predict the values in these different areas. And the first thing they did was the dotted dash line, regression line right in the middle, saying, ignore regions of world or ignore categorization. Let's just do the straight linear regression and whether satellite imagery predicts the particulate matter in other parts of the world. And they said, okay, we'll do the straight regression line, but let's color things by their region of the world. And they immediately saw the regression lines, if you care about different regions or categories, are very, very different from the overall regression line if you ignore them. So like if we want to be more descriptive and more predictive, we need to take into consideration that these regressions vary by these clusters. So this is an example of, you look at your first one where you just group all the data together and create one line and say that's not sufficient. And so you start creating variables that account for the regions of the world. And then it's another one of just modeling in a hierarchical fashion. Let's see if the first one is finished. So if yours is kicked off or still running, I think we finally made it to the 10:15 coffee break. So feel free to go do a break. And if you want to come back, these are the 3 exercises on different types of regression and the visualizations that support the analysis. So I'll stay here and be able to walk through them as soon as they're available. But thanks.